Okay, this is the first recitation on the absolutely essential subject of version control. Again, as a beginner, this could be somewhat frustrating, somewhat of a learning curve, and is one of the most useful things you'll end up learning from the class. So Julian, who manages our computing infrastructure, will take over. Go ahead.
Hi, good morning, everybody. Yeah, so as Neil says, I'm a programmer at trade, and I like to tinker around with servers. So I'm helping out with the Fab Foundation, managing all the servers and helping. So everyone got all their repos, and you should have got an email from with your password to log in. That's what my involvement is. And so yeah, I'm just going to go a bit today over a bit deep dive into Git in the various ways we can use it on our platforms that we have hosted for you, and also how to do this all locally on your computer. So we call everything that we hosting, we call it Fab Cloud. It's just a fancy name that created, I think, with Fiore, our previous infrastructure person. And we have 5 different services that we're hosting, which is the Fab Labs IO. It's a platform where you might have probably already seen it, where we connect a lot of labs together and map them out. And it's also where we will be using, you will be using the login of this site. So it's a single sign-on. So you log in through FabLabs.io to all the other platforms. So this is the only login form you'll ever need to fill in. All the other ones you can ignore because you should always be redirected to this form. And I'll show you a demo a bit about that. Then we have the GitLab server, where we host a GitLab open sourced version. And this is where we're hosting all the student repositories and where you'll be doing your work and pushing, which is different from the gitlab.com, where you can also have repos, which is hosted by the GitLab company. And we also have a Mattermost server where we can do all our chatting. I've already added all you students, all your accounts to the team for 2023. So you should have access to Mattermost if you would like to use it. Please let me know if anyone is at the end of this call, if anyone still hasn't gotten access, and let's try and work through those. And our last platform we have is Nueval, which is a custom evaluation platform built by Fiore. And this is where you will be updating your work, check marks, and I'll show you briefly, can show you that as well. And that's where you'll be evaluated and interact with your evaluators and instructors as well. So a bit about GitLab. GitLab was developed as an open source Git hosting platform, sort of competing with GitHub with alternative models. And it since has grown into this big tool that can do a lot of different things besides just hosting our code. And they've really tailored towards the developer and development, because we have the whole work cycle. So you can plan your work, you can code your work, then there's lots of like code verifying and testing mechanisms. There's a package repository, so you can host packages for different platforms, npm or Python. It's all integrated. There's CI, you can make releases a bit like GitHub does. Lots of monitoring, tracking tools, connecting to hosting providers like Google and Amazon. So it's a really huge tool if you want to use it that way. And we'll really be using a really small subset of that during your classes for basically the Git repos. So how we doing all the logins is, if you've tried to log into GitLab, you'll see that there's a login form, and below it there's a button called FabLabs.io. This is the button we would like to click, and that will redirect you to FabLabs.io, where you fill in your FabLabs.io login, and then we'll redirect you to Fab Cloud. So you don't need to use the login form. You can always just click the Fab Labs button, and then because you should already be logged in, or if you logged in before, if not, you log in once, and then it will be the same login for this, and then Mattermost is the same. So if I go to chat that, I'll just show you an example of how it will redirect me. I will view it in browser. So as an example here, you see there's a login form. For Mattermost, it's a bit different. I'm going through GitLab, which is in turn going to go to Fab.zo. But these are always the buttons, GitLab and Fab Cloud. And yeah, I mentioned this, but Fab.zo, we're using it for our login. So I hope you all have had access to Fab.zo, and otherwise after class, let me know. We're using it to host all your repositories for all the student repositories. We're also using it to host all the website for that Neil is showing you, where you have all the schedule and all the links to all the videos. That's actually also a repository. That's this site that's also a repository in GitLab. We have a place for instructors and the staff to write issues. Also, there's the class repo where the students, you can write issues and discuss, which are the project management. So we have the issues and the milestones. And I'll just briefly show you a bit what GitLab, for those who haven't gone to explore it. So if this is your first time, this is your dashboard, and these were all the projects that you have been a member of. So I have a few more, but you may have like 2 or 3 only. So you should see something where you're a student repo, and then you probably also are part of the class repository. So for example, I can go to the class repository, and this is just the default layout of your project. And we have here on the left, the menu where we have the repository where our code is hosted, and we have an issue links where we have our issue managers and boards and milestones. As you can see, we already have in the class project 4 issues that Neil created, which you also probably got notifications for, which is just a replicate. So every time someone posts an issue inside this repo, all the students that are a member of this repo will get a notification that a new issue has been created, or maybe someone commented on an issue. So we can look at an example. If someone posts below, then everyone will get that. So you keep that in mind, and when you write a comment, that everyone will get notified, and that's how we can get engagement. To verify a good point that might be interesting is to check what notification level you are for the class. So by default, I've set most students automatically already to the watch level, which means you'll get an email for every activity that happens in the repo. So for example, in the class project, every issue, every comment, everyone will get a notification. You'll get a notification. But you can also have a more restricted, if you don't like all those emails, you can say only if someone says my name, or a more restrictive, or disable it completely, because you're going to be checking it every day. But the watch one is just nice, just so everyone, you get all the notifications of all activities, and that way everyone's notified, and then they can contribute back to you, and you can contribute back to the class. Yeah. If we go one folder out to the 2023 group, this is where we store all the related repositories for this year. So we saw we were in the class. The site has the website where a lot of the links that you're using today, so you can see this project and make edits if you want, propose edits. For example, this is where we were getting the student agreements. Neil showed you, you have the docs folder, so you can navigate to it and find the files and then copy the contents. And the other, I have a overview. So this is sort of the overview that we have, where the main part is I want to show you is the lab. So you are all organized under labs. So the lab that you're participating in will have their own group, and within that there'll be a students group, and then each student is under that group, and that's how we've organized. And you can see if I open, here's the lab group in GitLab, you'll have a list of all the labs, and then you can find yours or a friend or someone who you've heard about, and you can go and watch see what they did as well in their code. So for example, I can open, then I have the student group, and I open that, and then I'll have, okay, here's a demo student I created. So this, for example, could be my project, and then I can look at my project. Remember here at the top, you can see the whole path of where you are in relation to all the groups and the projects. So here I can go back, and this is also where I can go back to another year. If I click all the way out of 23, I can click Fab Academy, and I can even visit all the codes for the previous years. So everything's open. You can see how everyone's done it, how it's done in previous years. It's the nature of Git and having it all open. So if I go back to this, my sample student projects, this is a bit what the project looks like. You have your name. This box here is the most recent commit that was made to the project. And these are the current, the list of the files for the current, the latest commit of your project. And so here you can browse your files. You can also visit your files from the left, clicking files. You can also see the history of your commits on the left side. You can have issues. You can also make your own issues that are just for this project. And you can, if you want to use it as a to-do thing or a project management, you can use your own issue tracker. And we also have the CD and pipeline, which I will get into a bit more later, where you have the progress of each commit and how it was published. Yeah. Okay, so what is Git? For those who haven't really gone down into the Git hole yet, the Git rabbit hole, Git is a tool for tracking changes to your files. And it's a great, it's an evolution of a lot of different other version control systems that have been used primarily to manage the code. And Git is a great new evolution because of this much more decentralized. So you can have repositories, lots of different repositories that are all following the same ancestry of commits, but that can don't deviate. So you can all work on your separate parts and separate computers all around the world. And Git will very easily provide you the tools to merge these changes and find a common pathway. If you have two files which are editing the same thing, they will give you the tools and easily show you how you can merge changes. So it was I find it a great tool for development, especially in groups. Although you'll mainly be coding yourself and pushing commits just by yourself on the repo. Maybe you have another computer, maybe your instructor will help you, and you'll come into times where you have merge conflicts, and these things are part of the Git and they help you. And you have to remember that Git is there to save you. Git has the history, Git has the log, and it's a great way not to lose work and to see what happens. And then you can also go back in time and change stuff. So this will be the rabbit hole that you will go down with Git as your project evolves. And maybe if you collaborate with other people on on group projects, group assignments, with your group repos, you'll have fun. I will say fun for using Git and managing your repos. So each change that you would like to make in Git, we call this a commit, which is the same as you can think of like in a Word file where you click save. It's the same, we call it a commit. It's basically we're telling this commit, this save, what changes are we making to the file. And that's wrapped up in a commit that we can write a message to. We can assign a context to what that change is about. And it's going to store what was changed, what file was changed, what line number, and the date. And everything, all bunch of commits together historically in line will create your repository, which is just all the history of all the commits and all the diversions that you have. And with Git, you can go through the history back in time and see your changes over time, which is, for example, great if something went wrong. You can go back and say, hey, what did I change yesterday, and see those changes. And I'll show you a bit later some examples how you can go back into your history and revert some changes. And that, yeah. Okay. I added here 2 links. I'll share the slide later where you can really go into the history of Git if you would really like to know more about how it evolved with the other version control systems that have come through that, and then how we landed to now Git being the dominant version control software. And there's lots of nice tools that you can also follow, that tutorials that help you really go if you really want to learn deep dive. I'm going to go through some basics today, just to really, so you can familiar yourselves with what you will need day to day with committing to your repo. So if we'll go back, so I'll go back to my repository, I'm going to show you the commits. Now, this one only has 1 commit, but I could go, for example, to the site repo, and just so you have an example with more commits. I go repository, commits. You see here, I can see all the commits that have happened, and then I can click 1 commit, and then I can see, okay, this commit, what was the date? Each commit has a special hash. This is the unique hash that identifies this commit. And then for each commit, you have the change log. So this is basically a new file, an index file, and this all the, you see all the pluses. That means these lines were added to this commit. And then there was also a change to the index file, and we have a negative and a plus. So the negative was a line was deleted, and the positive is a line was added. So this is a patch, and you can, GitLab is nicely showing us, well, actually only this part changed because it's comparing the 2 lines. And so this is the nice part about having a UI. You can see these changes a bit clearer. And so this is the graphical representation of a commit. So, you know, one reason is we like to have all the commits tracked so we can all work together and push changes together. But the other reason we're using GitLab is because there's a CD, a pipeline. Now, what is a pipeline? A pipeline is a sort of a scripting languages that will run every time we push a commit to the server. The GitLab CI will pull your repo down onto a server somewhere and then build your website. So, for example, if you're not using HTML, but maybe you're using you know, a static site generator, or you have a script that tests something, that you can use the CI pipeline to run these things every time you do a push. It could also be used, for example, to send a notification. Every time I push, make an API call to, you know, an SMS service, so that I get an SMS that tells me hello, you know, or you maybe find something in your project where you want every time you push your device could be notified. So you could use it a lot of different things. Use it for testing, integration, deploying code to servers, fetching code as well. And so it's really another big feature from GitLab, and we'll only really be using a small part of it, which is to deploy your website. So in your template, the most it's ever going to do is just package your HTML up and then just say, hey, here, deploy it to your GitLab pages. A bit more in detailed, each C file, each project will have a GitLab YAML file. The naming is very important, and you should have a dot in. So it's a hidden file in your system. So we'll see later, this file isn't always visible on some systems. So you really want to make sure your project has this file. So if you're changing your projects, this is something to keep out. And when you push the project, a runner, we have other servers that are basically watching every time there's a push. It will read your repo and check, does it have a YAML CI file? If it does, it will start a pipeline. And then it will read whatever's in whatever's inside your CI file, and then run those commands that you have written inside the CI file. And we use this with the student documentation to deploy to GitLab pages. So you see a lot of the jobs called pages, and we provided a public folder, and then that's what we give to pages to deploy. So it's very important that we have this file, and that we have a job called pages if you would like your documentation to get deployed. There are a few examples provided by GitLab, which if you want to change, you'll use different tooling or different libraries to build your projects. Please have a look here to see some common examples, for example, Hugo or Jekyll, to name a few.
Julian, there's a question in the chat about pipeline failures, about seeing what pipeline actually did.
Yeah, perfect. I mean, so this is where I was going to get to. When we push each commit, you will see that each commit has a pipeline. Now, we only really care about the most recent pipeline because when you're deploying a website, you can only have one copy of it. So it's whatever ran the most recent. So we can go see, okay, if our pipeline, we can see this one's green. So we know this commit, it went successfully. And I'm going to just go, I'm going to open the pipeline for this commit. So we can see this pipeline only ran for this commit. We have the hash of the commit. And then I can go visit it if I can browse the files if I want. And below here, I actually see the status. So this is basically what has been run for my project for this commit. And you can see it's running through a bunch of commands that are in my CI file. Now, what does a CI file look? It looks something like this, where you have we're basically running, these are run in Docker images. So you have to provide what kind of base system you want. So, sometimes you want Ubuntu. A lot of times there's like Hugo or MKDocs will provide you an image already with the tools installed already. So you don't have to install them each time you push a commit. So these are sort of like ready-to-made base images to run your jobs inside of. So you can see here, my job is called pages, and these are very important, the naming, and I'm going to attach the job to the stage deploy, and then there's the script line. And this is basically telling the CI what to do when I'm building this project, when I push. So for HTML, you don't need to do anything, but for example, if you have mkdocs, you would need to run the mkdocs command so that it converts your markdown into HTML. So we provided the public folder, and then we're telling GitLab, please take this public folder that was really just created and we're going to use it. And the CI automatically knows, oh, okay, if this job is called pages and I have a public folder, I need to deploy this website. So it's this nice integration we have with GitLab. And so these parts are very important. Whatever tool you use, that you have your artifacts set up like this with a public folder as your output. And also this part, although your image may be different depending. And I said, go to GitLab, look at examples of how other projects do it. So yeah, if we want to, let's say this doesn't go well and you have an error. I don't have an example error right now, but basically you'll have like, these are the commands we're running in this specific thing. You see, I'm making a directory, I'm copying some files. But let's say like, oh, suddenly this one, it will fail. You won't see the rest of the other lines. You'll just have a bunch of red text that will appear here saying an error. So you want to just go through this log and try and reverse engineer from the bottom up and try and figure out which command, which part is the error, because usually it will output you the error as if the command was run on your computer. You will actually get the message there that says, well, mkdocs failed to build because there was a misconfiguration in your configure file, or Hugo failed because you didn't install a plugin. So try and decipher those. You want to go up a bit from the bottom up until you have the red text, or until you see your commands. These are your commands that are been run. So for example, this would be mkk install. And it can depend. Sometimes these are mistakes that based on the previous commit you made, or maybe sometimes a new version was released that breaks something. So you want to basically either upgrade your code or make sure that the version installed of the plugin or the mkdocs, for example, is a previous version where it didn't break. And so it's sort of reverse engineering, and you'll get the hang of it and see. So usually sometimes like mkdocs, the common one is, just a misconfiguration file, or an image is missing or something. And so work your way from the bottom to top and sort of try and figure out where your errors are. A lot of it in the beginning is just boilerplate. This is just the server downloading the Docker image that you had configured in your CI file. It's cloning the repository into the Docker image so that you can run some tasks, and then basically it will start executing your steps here. Sorry, this line. So that's a bit how to read the log file. It will make more sense, I think, if you read the logs that are part of your project. And if you just have an HTML, if you just have a, like from the template, for example, mine that we've set up, there isn't a lot doing. All it's doing is copying the files to the public folder. So probably you will never ever see this fail unless there's something wrong with the servers infrastructurally. And so if you can't figure it out, come into chat and let us know. Maybe someone helps, or maybe I'm there. Maybe there's a fire to put out. I don't know. Things can happen over the course of the year. So yeah, some pipelines may be simple, some may be more complicated, and may break more frequently. It depends how you have set it up. So I hope that helps to sort of read the pipeline. And the last thing I'll say about the pipeline is, again, always the most latest. So if you have, I'll go back to one with a lot, always the most recent pipeline is the most important. So if you have, if let's say this one failed, you can ignore it if the one after it, if there's one after it, that's the one that matters, is the top one, the most recent. So you can ignore all the
Lorenzo,
one more question about pipeline for Hugo in the chat.
Dime. Sí. Es el mismo, el antiguo. Ya te envío.
Sorry, somebody needs to be muted. Just in the chat, there's a question about
so for example,
for building Hugo.
Yeah, you can, if you've already set up your website, then the only thing you would need to do is, yes, copy the example. For example, copy this example would be my go-to, and start there. I think they're pretty good defaults set out by Hugo. I'm not sure. Yeah, let me know if you have it. I know there's a few instructors that have. Maybe we can post some snippets. Actually, I think I do have some snippets. All right. Yeah, the last thing about the CI is, again, remember there's a dot in the file name. So if you're doing this on your computer, sometimes the dot won't get added. You'll have to do it through the terminal, or just make sure sometimes a normal file gets created without the dot. And so it really needs the .GitLab. It needs to be called like this, and you'll see it work because you will have the circle next to commit. If you don't have a circle next to commit, there's no CI file being read for your commits. Yeah. Okay. Well, that's. I think that's all I want to say about the UI. I think you'll be able to find your way around. What I'll do is I'll show you briefly how to edit. So I'm going to do two things. I'm going to show you how we can do some edits inside GitLab with the GitLab tools, and how we'll then do it locally. I think locally is quite a powerful tool. It requires a bit more setup, but the one through the web interface is a quite quick one if you need to make some quick changes. And I think a lot of you will have already experimented. Neil showed you in class the web ID. I'll just do a quick run through it. So when I open the webd for my project, I see all my files on the left. I see there's a public folder for my base template, and then I can click files and I can make changes. So for example, I've opened the index file, and I can say hello. And that's my change. I can, see all the other files. So when I want to commit the file, I can go to the left to commit, button. And here I can just review again, review the changes. It's always a good idea to check to make sure that I actually make this change. I can see that the left is what it was and the right is what it's going to change to. I can scroll down the file and see all the changes. In this instance, I only have one file that I'm changing, but there could be multiple that you do in one go. You don't have to do one change per commit. You can make a few commits. If you're uploading image, you would upload the image and you would have a file name change. We need to add the link in the file. To commit, most times if you're just working by yourself, you really want to click the commit directly to the main branch, which is the branch which is the default branch that your project is listening for, and it's also where the CI file will build your project. If you're just doing an experiment and you don't want to publish this right away, you could create a new branch, and then later on you could merge this back into the main when you're ready for this change. And so that just depends on your workflows, how you want to work. But by default, if you want your change to go live right away, commit to main, and then write a little message adding, just so I know what this change is about. And the comment message is always nice because when you're going back in your history, it's nice sometimes to know if there was a change. By default, GitLab will just say which file you're updating. It will write a message for you. And then in this view, in the web ID view, I can see at the bottom, if you notice, there is a GitLab pipeline that says this commit was just made, and then I can see already the status of the pipeline. It already just went to past. So it's just within this editor, I can just keep making changes. I don't need to leave the project, and I can see my pipeline, the latest pipeline running at the bottom. So this is a great way to do your first few edits, or edits if you're away from the computer, or you just want to, it's a nice tool. Works very well. You can upload files. If I want to upload a file to the image folder, there's a little drop down, and I can say then upload file, and then I can pick a file from my project. And the same works if I would like to add a new file. For example, if I want to add a new week, I can say, well, let's get a new file. And then this is I can name the project. So say week 02. This will now be making a new file called week 2 inside it. And this is the path that, because I clicked the assignment folder. Then I'll say create. And then I'll have an empty file. So for example, in this example, I can go to the week 1 and I can just copy everything and then I paste it in there. So I have already something to work with. And this is so I can write a little message, week 2. I might want to go to my index page and also update here. I want to update the link. So for example, which is the path to the new file I just created. Whoops. And this is your HTML. So now I've just added a link to my home page to the new file that I just created. And I think I'm ready to commit, so I can click commit. And again, here's now defaulting to the main. I'm checking, okay, yes, commit to the main and adding week 2 file. And I can commit, and there we go. Commit published. I can also see, I can also click the commit, and then I can view the commit. Here's the pipeline. I can just watch it going. These are the changes I made. And I can go in history. You can see these are the 2 commits I just made. So I can do everything from this interface, and probably you can do a lot just from there. But as you notice, I don't get to see the changes before I save them. I have to wait till before the pipeline fails, before it gets published online. So now if I refresh, okay, now it's published. And now I have the week 2, and I can click it. I got my week 2 file. So yeah, if you want a bit more of a quicker development where you can really do a bunch of stuff and see how it looks and experiment, the ideal would be to download the website to your computer and do the work there, and then push your commits up from your computer. So to do that, we'll have to set up Git on our computers. There's a lot of different computers and operating system. I didn't think to list them all, but the default, their website will show you a bit some installation methods for Mac OS and Windows and Linux. Try and go there, find one that suits you, whether for example, Mac, you can use the brew. You can use, a lot of them ship with defaults. You don't really need to install it. Windows, I'm not sure. Linux, there's lots of different platforms and they can help you install it. So it should be quite simple to install GitLab. So if you have problems, ask your instructor to debug with you. If not, let's look through Mattermost and we can try and figure it out. Lots of different computers, sometimes weird setups can happen, some conflicts. After we install Git, we need to set up a way of authenticating with the server. So whenever you're pushing your commits up from your computer to GitLab, you need to be able to have a way to tell, hey, this is me, and I have the rights to add these Git commits to I'm going to go to my demo. I'm going to first show you how can I download this project. So actually, we can just use this by checking we have Git. So if I go to my terminal, I'm going to check that I have Git. Okay, I have Git installed. So this is a good way to check it works and it's working in your terminal. I'm inside a terminal browser. Yeah. So if I want to clone this repo, I need to fetch the URL of to clone it. Now there's two ways to clone it. There's what we have the SSH way, which is cloning the repo through the SSH protocol, which is a way of communicating with a server. Or we can clone the repo with HTTPS, which is the normal port 80 or port 443 port, which all websites go through. So there might be instances maybe where your network is blocking SSH port or something. So HTTPS is a good way of cloning the repo if you have problems accessing through SSH. The minor key difference here is that with HTTPS, you would need to provide your username and password every time you would want to commit, the same one that you would log into with in the browser. So it's a bit more work because every time you want to push, you'll need to type in the password. I think there are some ways to save it, but it's a bit more involved. But with the SSH way, you can set up the key you can set up a key on your computer and tell GitLab what your key is, and that way it knows, hey, this is this person's key tied to your user account. But it requires more setup. The HTTPS way, you can just install on any computer without SSH and username and passwords. I think, right? That would be my. So for example, I'm going to try the Git SSH. I think it's a default way. We should try to use it. If you don't, so I'm going to write git clone, which is the command used. Okay, let's clone this repo locally to my computer. It's going to download it. I'm going to paste the URL to the repo. And then I'm going to then click spacebar, and then I'm going to name it. So I'm going to say So I can name it whatever I want. This is the folder name on my computer, so I can choose whatever name I want. And then I'm going to click enter, and it's going to start downloading the repo. I see it's pretty quick because it's a small repo. So now if I go into my projects, CD is the command, so change directory. It's a Linux command. I'm going to go inside it. Your terminal might look a bit different to mine. And now I'm going to look at the files, going to list all the files, and I can see, oh yeah, I have a README file and I have a public folder. This is very similar to what I have here. I was like, oh, but where's the CI file? That's actually a hidden folder. So I can do it again, ls a list, and then I can say A for all files, and then I can see 2 hidden files. This is my CI file, but we also have a Git folder. this is the folder that holds your repository. So this is the one that holds the history, all the commits, all the configurations, the URL. So if we look inside it, you can see we have the config file, we have a pointer, which is this is the head, which is telling you which commit you're pointed to, and all the actual files for the repository. So you have the full repository installed here. So if I do git log, oh wait, let me just do like this. So you can see here I've done git log, and I have the same log that we're looking at in when I'm looking at the history log through the web UI. So I have the 3 commits. I can also look at the history log here. And a nice interesting thing is in my repository, this is my local pointer, because in Git, your current repository where your folders are, like if I'm looking at right, these files that I have now on my computer, or if you can imagine, also, if I'm looking at it on my desktop, these are the files. This is the current working directory. Right? So this is what I'm actually working on. This is what I see. That's your head. That's where you are right now. So I'm on this commit. Now, by saying that, I could move the head to another commit. So I can move the head, go back 1 commit. So I won't see any more of the changes in this file. I'll be here. And this is the great thing about commit. So you can go back and you can see different changes. And main is the name of my branch locally. And the origin main, this is basically saying where is origin is the name that's by default given to the repository on the server, the upstream server. So our GitLab repository. Where is your where's the repository local on the main server? So right now they're both pointed to the same commit. But what happens now if I make a commit? So if I would say, well, I'm going to use Vim. It's just an editor locally in the browser. I'm going to say Vim index.html, or sorry, it's not index, it's public index.html. I'm going to make an edit to this file. And I'm going to go down. I'm going to see, oh, well, look, my title is not set. So I'm going to put my name here. And then I'm going to save it. So now if I'm going to write git status is going to tell me what is the current status of my Git repository. And basically we're going to use this to see what has changed and what still needs to be committed. And so it's telling me, okay, well, you're synchronized with your branch on the remote GitLab repository, but you have some changes that have not been committed yet. And so I can see, well, yes, that's true. I committed the index file. So I can then now say, okay, well, I'm ready to make this change. How do I change it? So Git has three stages. Sorry, let me go. I wanted to show you this view. So we said on my computer, I have the working directory. This is where I'm making all my changes. But when I want to commit the file, I need to tell Git, hey, which files and which changes I would like to make. So I have to tell it, hey, okay, I want to commit my index file, and we're gonna call it, we call this staging. So we have to move the file, say, okay, move the changes that you did in index file, mark them, and so they get moved to the staging area, and they're marked for commit. That tells Git that whenever you start committing, I'm going to commit anything in the staging area. Once you commit, then it gets sent to the created in the Git history, and it's committed to the Git history. And then further, if you push it up to the GitLab, it also gets synchronized with GitLab. So we have these 2 steps where I first need to tell Git which files I want to commit. So I'm going to say git add public index. And now I've added the index file. So if I do git status, I'll now see, okay, well, these are the changes that need to be committed. It's now moved into the to be committed stage, which is the staging area. So it's okay. So now I'm ready to commit. And the commit command is git commit. And then I'm going to provide it a message. So I'm going to M, and I'm going to write in quotes, and I say, change my title. Press enter. And I can see it's confirming me that on the main branch, this is the commit history, it's made one file change. If I would go back to the log, I can see, oh yeah, here's my new commit that I just made. And I can see that, well, my current head on my computer is now at this new commit that I've created. But the origin server, the upstream one, is still pointing at add week. And I can verify this by when I go to my repository in GitLab, it's not showing here. So what we have to do is we have to publish the commits that we have made on this computer. We have to publish them up. And we call this pushing. So we have to push the changes up. And you can say, well, okay, I want to push to the origin server, the main branch. I want to push the main branch to the origin server. You don't have to do this. You can just click right git push and it will just default to the current branch you're in, because it already knows that it's called tracking, where by default the branch we're in is already connected, let's say linked to the same one with the same name in the GitLab upstream, in our GitLab server online. So I can just write git push. And if I write git push, it will start compressing it, creating commits and uploading it. And now you can see, okay, the git has gone on the server, has gone from this commit all the way to this commit. Now I can verify this in my log. You can see now, orange has been moved up to here. I can go back to my repository and I should see a new commit here. There you go, change my title. And I've got my, and the commit passed. So I'm very happy. I could verify my changes. And oh yeah, there's a change I made. But I skipped this step, which was to set up, to set up your SSH keys. So the easiest way to get GitLab and your computer hooked up so GitLab knows this is your computer and this is your repository, is we have to set up an SSH key. So if you've never set up an SSH key, please visit the documentation on GitLab. On GitLab's website, it's great. It's got a lot of information. You can sort of understand the different keys and the different commands you can write. But by default, for example, on my Mac, I'm going to just create a key of this type. I'm going to put my email address as a comment. And then what you will have is you have like a file called, you'll get a file like this where you have to say, okay, usually it's stored in your home folder. So you have like this .ssh file. And then the file name. So whatever you put here is where your key will be saved. And then what's important is that you need to get the public key out of so the key creates two files. It's a private key and a public key. The public key is the one that you can share with the outside world, or let's say with GitLab, basically because your Git repository is going to use your private key when communicating with the server, and then the GitLab will use your public. Together, they'll be able to like make a join and say, oh yes, they match. So it's very important that you only upload your public key. And this can be done in the profile of your project. So you can go to preferences at the top right here, and then you can click SSH, and then you can here upload, paste your public key inside. And then you'll see at the bottom, it should say, well, okay, this is your public key. And now when you push, GitLab will, and I think that there is a command to check that it works. And if I remember, yeah, verifying. So we've got this command here that I'll show you what it looks like. If I want to check my, actually be GitLab fabcloud.org. So if you noticed in my project, sorry if I'm jumping around too much. let's take, where was my? Yeah, so if you notice, I just wanted to show you that the Git URL is the same as the first part of the clone URL. So I can just type it. It's basically, because it's the same, SSH is the same protocol, we're just going to run SSH, a command. I hope you have it if you don't. And what I'm looking for is it should say, welcome GitLab, hello Julian. And then you know, okay, that's me. So you know it's made the connection, it's recognized you, and you should be able to now do git push. So of course, if you get an error with permissions, it's usually the SS key. There can be issues. If you have other SSH keys that you use with other projects and other accounts like GitHub, look at the GitLab documentation. They talk to you how to use different keys. For example, you can use a configuration file, an SSH configuration file. So you can say, hey, different domains can get different keys. So you can have a key per, an SSH key for a Fab Cloud and an SSH key for GitHub, two different keys. So hopefully that went well and you tested it and you can push. So make a local change, make a local change, add your change, commit your change, and then push your change, and hopefully it will go through and verify that it appeared in GitLab. I did skip over one thing with setting up your repo. So after you clone it, it's a good idea to configure your repo with your name and the email address, so that if you notice, when I did git log, you can see each commit has an author, and an author has a name and an email. And so this is basically a way to attribute the commits to you. And it's a Git thing, and in GitLab, if you use the same email address in your commit log that you configured in your repo as you use in your GitLab account, then you will have the user profile will be shown here as the committer. So then you will have yours. I can click it. I can see all the commits that are attributed to you. Otherwise, it won't know who that committer is, and it just shows the name, whatever you committed. But so you can, I would suggest, yeah, please set up your repository after cloning that it uses the same email that you use in GitLab. You can also change the email in GitLab and then change it here as well. And this is the command to just to do it inside your repo. So I can write here. And now if I want to say new, I'm going to add my new file. I'm going to commit my new file just to show you. And now you can see, remember I changed my name to test name. Now I have my name is the test name. So whenever I make a commit with this configuration, it's going to use test name as my name. Or I can put it back to my name now. And then if I make a commit, it might be my name. So please, yeah, make it put it your name and your email address, so your commits can be attributed to you. And then also in GitLab, it knows that it's you. And you can verify that by making a commit and then checking the Git log that it works. Yeah. So let's say now I committed something, but it was too big and it fails. Like, how do I go back? Because let's say now I haven't pushed anything. Now this is the key. Like, hopefully you haven't pushed yet because it failed, obviously. So I can say, okay, I want to go back. I want to undo what I did. Or you may say, I want to change what I did. So let's say if I want to rename so I would say like move, what was it, the new file, I want to say, so I've got this new file, and it's going to say, well, okay, you deleted the file, and now there's also a new file that's never been committed before. It's called on track. It's a file that it has never been committed. So I can say, well, add the projects, and and git remove new file. So I'm telling Git that I removed this file. So now it's actually, because I've staged both those changes, the deletion and the new file, Git has actually said, well, actually, you just renamed it. I could make a new commit, but because I haven't pushed anything yet, I can just change this one. I can just amend it. I can edit it because I haven't pushed any. I haven't pushed it up to the server, so it's only my computer has it. So I can actually say git commit and then write amend. And now I can, it's asking me, okay, well, what do you want your new message to be? So I can say new project file. So remember the old commit was called new file, and then I can save this. And now if I look at my Git log, I have, it's the old commit's gone. It's now, this is the next commit, new project, even though it was the next one in the list. So I've just edited, I've got a new code because you changed the hash. The hash is based on the changes. And now I can push it. So for example, this is great if you committed by accidentally an image that's too big and it failed to push, you can just amend the commit with a smaller image. Now, if you've really gone, if you already pushed the image, we don't really support you doing force pushes because there's a lot that could go wrong. But for example, on the server, we're already here, but let's say I want to go back to this commit. I could restore, so I could say git reset. I'm going to do a hard reset. So I'm going to delete everything, and I want to go back to this commit. So this is the reset command. You see, press enter, and it says, okay, I've now moved there. And if I do git log, you see, I've got only 2 commits because I've gone back in time. But I won't be able to push this because GitLab is going to tell me, no, you're trying to rewrite history. And then there's a lot of protections for that. So we have it disabled to prevent you overriding history that you've already deployed. But if you really, gone into a big dark hole and you really want help, I can help you. I can allow the reset just temporarily, and you can force push if you know what you're doing. But otherwise, yeah, if I've got time, I wanted to show you one more crucial. So
Julian, Pablo's asking an important question about the size of a repo when you delete a large file. Just explaining how it lives on in the history.
Yeah. I need to go back now. Oh, wait, I can just do this. I can go git. I'm going to reset it to wherever the origin server is at. So change my title. So yeah, this is the log. We have this file, which I showed was the .git file. This file is where actually the whole repository is stored. So, whoops, 1 second. So you have for example, if I want to see the file size of my public folder, you can see it's 64 kilobytes. If I want to see the size of my Git repo, of my the current folder, of the whole folder, it's much larger. Why is that? That's because we have this Git folder which contains the whole history of all the changes. So even if I delete an image, it's still going to be an object inside here. It's still going to be stored because the history is kept forever, and it allows you to go back. Like, what happens if I want to bring the image back? So Git stores all this. This is why your home folder will be a lot bigger. But if I just look at my Git folder, see it's a bit less because the Git folder minus the public folder, right? So you can it will look like your folder is way bigger than it is. What's important is how big is for us really is how big is the size of your project right now. So it's how big is your public folder. So, if you've uploaded by accident a large image, you can just, the damage done, so to recompress it, bring it down smaller, commit it, and then your public folder will shrink. The current one, your working copy, and also what's deployed, because what matters is also what's deployed on the website, because that's what people, if people have to download a 5 megabyte picture, that's going to take a long time. So the Git history is sort of, yeah, keep an eye on it. Things can happen. You might accidentally commit. If it's really bad, we can help you force push and revert those changes. But just keep moving forward, you know, like if you want to start over, you can just go to the whole thing and just delete all the files and then paste in some new files. And then, you know, so now if you look at my status, it's all gone. And then I can paste in like an mkdoc, so I can paste different images. But this is why it's really key to, like, yeah, try and get your images optimized before committing and before pushing. Julian,
what else did you want to cover? We try to keep it to an hour.
Yeah, I think this is good. I've got some commands here, brief overview. What can happen? This is an error, for example, that you probably get a lot, is if your commits are too big. If you commit an image of more than, sorry, we don't support, we have a maximum limit of 10 megabytes per commit. So that's not per push, it's per commit. So if you commit, if you have one large image or one large 2D file in one commit and it's larger than 10 megabytes, you're going to get this error. It's basically GitLab. So just so you recognize it, halfway through, it says something about the package exceeds the maximum allowed. So you know, oh, this is because my commits are too large. All other kinds of errors, yeah, it could be permission. So this was just a common one, and I would wanted to share with you. So if you recognize this, just amend your commit and make them smaller, or split them up, or, you know, split the commits up in lots of different.
And
yeah.
Stephen is asking about using a local GUI. I don't think Julian mentioned this. There's a number of GUIs that you can run locally. Stephen, that's of course fine. We don't ever regulate things like that. The only comment is, as you get better at Git, the GUI.
¿Abriste el video? ¿Abriste el video?
Sorry, who's talking? As you get better at Git, the GUIs are frustrating compared to just typing a few command lines. So I tend to use the GUIs when I'm doing something very complex, going into history, or where I need to visualize it. Other than that, you might find the command lines efficient, but there's a number of good local GUIs.
Yeah, it's just like, for example, this is an overview. You can see here I have, it might be confusing, but, you know, I've got, okay, I've staged this to be committed, so it's got an A to add, you know, so it's a very visual representation. You can do stuff very quickly. I can see the history as well, so the log. So yeah, there's lots of different, there's some integrated with your editors, but keep in mind, when you make your commits, I always recommend review what you're going to commit. Don't just commit, just commit all changes and then deploy it. And then, you know, you notice way later, you committed way more than you wanted to. Maybe you committed a password, you know, so just always double check your staging, what you're going to commit, and before pushing.
And then just, yeah, 2 other notes. It is really important to wean yourself off of the web UI and get set up to push and pull locally. You'll be much more productive. Initially, when you do it, you'll have problems. Read the error messages. Git error messages are good, and usually the resolution, it's trying to tell you what you need to know. We'll help you, but read the error messages.
Yeah, and I'll just add there is an mkdoc template if you would like to go back, if you would like to use mkdocs in Markdown. There is the template, basically how we have also a similar setup with assignments. So you can have a look at this one and copy it if you don't want to use HTML and you don't feel comfortable setting it up yourself.
Okay.
Oh, that's it. And enjoy. Good luck. And let me know in Mattermost if you have issues.
I'm going to stop recording now. Julian, really nice job giving the tour. I'll stop recording, but I imagine Julian can stay on if there's any follow-on questions.
Okay.